Welcome everyone. Today I'm going to discuss the subject how good is ChatGPT solving general relativity equations. As you know, general relativity has a lot of mathematics, tensors, covariant derivatives, etc. So it has plenty of mathematics, and ChatGPT has improved. It has improved a lot. So I try to solve general relativity problems using ChatGPT, and I'm going to discuss what it can do and what it cannot do. There are certain things it does, and it does pretty fast, and certain things it cannot do. So, first thing I did was I took a metric. I took a metric that is curved metric. I just took from nowhere. I just said my metric was x squared plus xy squared t. That was my metric. So that has no physical meaning. I just want to know whether it can do the math. So I asked it to find the Christoffel symbol, and it did in seconds. There was no issue. And then I asked it to find the Ricci tensor, and it took like 30 seconds, 45 seconds, but it still did. And then then I asked it to find the Ricci scalar, and then it gave me a Python program. But I said, now, can you do it for me? But then it says I have to get plus, ChatGPT plus, which is, you have to pay more or something. But I think that it can do it because basically I came up with the impression that it can solve, once the metric is given, it can solve for the left-hand side of Einstein's field equations. It can solve, once the metric is given, it can solve for Christoffel symbols, Ricci or Riemann tensor, Ricci scalar, these items that it can solve once the metric is given. Now, in most cases that we encounter in physically, like Earth going around the sun or satellite going around the Earth, our stress energy tensor is 0. So if you can come up with a metric, then the stress energy tensor is 0, then we could get an answer. But the metric is already known, the Schwarzschild metric. So I said, let me try the Schwarzschild metric, which is much more difficult than the metric that I gave for testing. And it did calculate the Christoffel symbols, Ricci scalar, and Riemann tensor, and all that. Fine. So these things it can do. So now, next thing is what it cannot do. Now, as you know, like if we are talking solution in a vacuum, then stress energy tensor is 0. But if we are talking something else where the stress energy tensor is not 0, then we need to input the stress energy tensor. But you cannot input the stress energy tensor without knowing the state equation, without knowing the geometry of the space-time. So you need to know the geometry, how to guess. There is a lot of guesswork involved. And that's the part ChatGPT will not be able to do. So for a given situation, like around a black hole, the matter distribution, the etc. So we cannot develop the stress energy tensor without knowing the geometry, and this we need to get the state equations, and that's involve back and forth guesswork, and I don't think ChatGPT will be able to do it. And unfortunately, I'm not versed enough in general relativity to check ChatGPT on that type of situation. It would involve a lot of calculations. So So those are things it can do and it cannot do. So that to summarize, if you give the metric, it can go through the equations and it could find the Christoffel symbol, the Ricci scalar, Riemann tensor, all that until added, it could do it. But if you are looking for a physical, realistic situation where you have to guess the geometry and the stress energy tensor based on the geometry, then ChatGPT will not be able to come up with a solution. So that was my conclusion. But in the future, it would develop enough to, we just describe our situation and it would come up with a metric and it would come up with a stress energy tensor, state equation, and first you have to come up with the state equations. And in the future, it might be able to do all that. But right now, I don't think it is capable of doing that. Thank you very much. I hope this would have been helpful.